many things have already been said this morning about aging and what it is, so I will not go into a lot of details. I will just try to draw main ideas about what is the role, what is the problem, and what is the role of the regulatory authority. First, I called my presentation time-dependent safety, because I would like to separate two aspects. One is the aging, in my definition, which are time-dependent phenomena that can result into degradation of material and equipment. And examples have been given: corrosion, cracking, wear, and so on. And with respect to aging, the challenge for safety is to maintain compliance with the current safety requirements. This is a very general sentence, but what you mean is that you don't want degradation of material to be too high, and then the plant doesn't require to, it doesn't comply with the current requirements. And then you have a second challenge in safety, depending upon time, is what I call safety reevaluation. And this was already mentioned, but I say it again, safety requirements for new installation are becoming stronger and stronger. And this increases the difference, if you do nothing, between the safety of the new installation and the safety of the existing installation. Practically speaking, in France, we are building an EPR. The level of safety of EPR is significantly higher than the current safety level of our 900 megawatts, which are the oldest one. And then from a safety point of view, the challenge to enhance as much as possible the safety of old installation compared to the new ones. So I will come back to this issue, but I wanted to make this very clear. And one thing I want to say also is that the challenge, you have to fulfill both challenges. They are both necessary, and what you cannot do is compensate one by the other. You have slight possibilities, but basically they are both necessary. The general process in France, we have for aging continuous control through inspection, event assessment, requirements that are made on a event by event basis, and as was also said by EDF, periodic safety review for aging and reevaluation, meaning that every 10 years there is an in-depth assessment made of each plant. And this in-depth assessment is involved with aging management in the sense that I have described, but also safety reevaluation. So that means that every 10 years for each plant there is an update of the appreciation of risk and drawbacks, of taking into account the past operational experience in France and also international, new knowledge, and also requirements for new installation. Now I'm going to speak first a bit about aging, and then I will speak about safety reevaluation. I gave you here, I like to illustrate what I'm talking about, so I picked up a few photographs of aging problems. The first is in France, corrosion in an essential service water pipe, and then that damaged the concrete. Then I've taken a US reactor pressure vessel closure head degradation. This is very well known in Davis Basin case where you had corrosion by boric acid. And the last one is a cracking. It's not very clear on the photograph, but you see that there is some grass that is growing at the bottom of this chemical product tank. That means that the metallic retention that should pick up the chemical liquid if it leaks is obviously cracked. So these are the type of problem we have to deal with. Just let me detail a little bit what we are controlling in the field of this physical aging. We have basically several levels. First, we check that at the design stage, before a plant is constructed, those phenomena are taken into account, and that the whole setup of the plant is minimizing the risk of important degradation. Then, I'm not going to go into the detail of the transparency. Then, during the lifetime of a plant, the second thing the regulator is controlling is whether the utility is performing adequate surveillance of this aging mechanism. Then the the last thing is that we control that necessary repair, modification, or replacement of equipment are performed. And this, to give you examples, this was, for example, performed in France when the EDF saw that there were cracks in the pipes on the vessel head, and all of the vessel covers were replaced, and this was achieved in 2009. And the most sensitive steam generators were also replaced between the third 10 years outage. What is also important, and this has been said this morning, is that the utility has to anticipate operation and ensure that large programs are compatible with industrial capacity. And this is a request from the ASN. It's true that when you have to replace big components like steam generator, for example, or cover head, it's not so difficult to completely saturate the national or even international industrial capacity. So we are requesting EDF to look at those problems in advance. And this was also said before, specific control of non-replaceable equipment, reactor vessel and containment building. About the cost of the reactor building, as a regulator, if EDF was coming to me saying, we have a problem and we will construct a new containment building, I would have to check with the Commission, but personally I would say yes, but I doubt very much that they would propose something like this, because obviously we know that the cost would be too much. Okay. Just a word about the institutional role of ASN in the aging management process. There was a formal introduction of a specific program that was initiated by ASN in 2001 as a response to the life management project of EDF, sorry. And there were specific ASN requests in 2002 for developing a specific approach to it. So we have the specific program that was also mentioned this morning. Let me talk now about the second big component, which is safety reevaluation. I already mentioned that safety reevaluation is a part of the periodic safety review required every 10 years by the French law. And in a bit more precise way, what is done in those safety reevaluations is to reevaluate, reevaluate and improve the safety of the installation with regard to national and international operating experience, evolution of knowledge, research knowledge, probabilistic safety assessment, and any other available knowledge, and also requirements for new installations. So, to put it in a specific way, and taking into account the French situation, EPR-type reactors will be commissioned in France in the coming years. Okay. Maybe this is a bit awkward sentence. At least one will be commissioned in the following years. Several others. And it's true that EPR design, and this is the judgment of the regulator, is achieving significant safety improvements compared to existing reactors. And EPR is consistent with the WENRA objective for new reactors. And then that means that for reevaluation of all reactors, we are using the safety objective as a reference to require reasonably achievable enhancements for the reactor in operation. In other words, we take the WENRA reference levels, which were written for new reactors. We use those requirements as a reference, and we ask EDF, to make it very simple, what do you propose in order to come as close as possible to be compliant with those requirements. And also one word about the relative responsibilities of the regulator and of the utility. And again, I'm trying to highlight the main ideas. The first responsibility of the regulator is to determine what are the new requirements for further operation of all plants in the sense of safety evaluation. So this is our main responsibility. What should you achieve? What should the utility achieve in order to be allowed to operate further the plants? And the utility has basically two main responsibilities at this stage: is to decide whether cost of enhancements or enhancement is economically acceptable or shut down the plant. So it's at this stage they have to evaluate what is the cost of the requirement and whether this is economically feasible. And in case they think or they choose as a strategy that it is more profitable to improve the plants, then they have to submit to the regulator for his approval the exact measures they propose to take, and then they are assessed, of course, with, in relation with ASN, and the final decision is made by the regulator. And one last word, we're coming back to the operation between 40 years of 900 megawatt French reactors. This is actually proposed by EDF. This is still to be assessed, and at the present time, the French ASN finds it impossible to predict any conclusion to the process. Actually, in 2015, we will say whether we agree and what decision we take concerning the main strategical approach of EDF, but the final decision will be made in 2018 or 19. So this is a long and anyway difficult road in front of us. So to finish with other pictures, some examples of improvements that are resulting from safety reevaluation. The first one is relative to flooding. So in Blaye there were improvements in terms of wall and underground screen. The one on the top left is hydrogen recombiners. Initially our reactors didn't have recombiners, so with the reevaluation we required from EDF to have recombiners, and then also the venting filtration in order to reduce the consequences of severe accident. So as a conclusion, I would just highlight the importance of continuous control of aging. This is very important, and it's a necessary condition, but also the importance of periodic safety review. And again, there is a fundamental difference between the two. Aging management as a primary objective to maintain compliance of the plant with the current safety requirements. And the second one, safety requirements as an objective to enhance the safety by comparison with the requirements applicable to new installations. And again, there are slight relations between them, but they are fundamentally independent objectives. We have to manage time-dependent safety. Thank you very much for your attention.